All right, this is the last section of the chapter 4 notes. So we're going to graph these two types of equations today, and after we graph them, you're going to see they look like stairs. That's why they're called step functions. Okay, now there are some symbols for round up and round down. First of all, that means to round down. So if you see something that looks like that, that is round down. This one is round up. So if you see something that looks like that, that means to round up. Now there are two other ones for round down. Let's check it out real quick. I'm not going to worry about those at this time. I only care about those two. So you can just cross off the other two blanks. And I don't care about the names of them. We're going to just stick with round up and round down. Okay, so let's go ahead and graph them. So first of all, here's the origin. Make the origin on all of them. Okay, so the first thing you want to do is look to see if you have to move your origin. So I don't have any extra numbers, so I don't have to move it. So I'm going to put a point at 0, 0. And then I'm going to put points on the diagonal. 3 or 4 is probably fine. And this means to round down. Therefore, if I'm rounding down, I want the number on the left or down to be closed in. So that means that the ones on the right are going to be open. Okay, number 6, again, I just put a point on 0, 0. Put points on the diagonal going up. And this time this means to round up. So if I round a number up, I want the number that's on the right side. So, therefore, these are going to be on the right side, and the open points are going to be on the left. And then, technically, my graph keeps on going. Instead of putting arrows, I'm just going to put little dots to show that it keeps on going in both directions. All right, so now I'm getting into actual numbers. So this one is with x, so I'm going to do the opposite. So I'm going to go to the right 3. So from here, I'm going to go to the right 3, put a point there, and then I put points on the diagonal going up. And that means to round down. Therefore, my graph should look something like that. So the closed points are going to be on the left, and the open points are going to be on the right. And then I got to show that it keeps on going. Okay, on number 8, this number is by itself, so I'm going to go down 3. So 1, 2, 3. Put points on the diagonal. And this time it's also round down. So I want them to look like that again. So the closed points are going to be on the left, and the open ones are going to be on the right. And then it keeps on going. Okay, let's move on. Okay, so here's my origin. Okay, so this time I'm going to go to the right one up 2. Put a point on the diagonal, or I'm sorry, at -1, 2. Then I put points on the diagonal, and this time it's round up, so my points are going to look like that. Let me see something really quick. Okay, so that means that these points are going to stay on the right, and the open points are going to be on the left. And then finally, number 10. I'm going to go to the left 2, up 3. There's my starting point. Then I'm going to put points on the diagonal. This one's also round up, so I want it to look like this. So the closed points are going to be on the right. The open points are going to be on the left. And then it keeps on going. Okay, So those are step functions. Let's move on to inverse functions. So this right here means inverse. If you see a little -1, that means I'm looking at an inverse. For example, we already mentioned in previous lessons that if I have a number in parentheses, those are the x values. However, if I have a number in parentheses and then there's a -1 as an exponent, those are actually the y values. So just to be clear, these are the x values and these are the y values. So what I'm going to do is I'm going to find -3 in the x column and the y value is 0. I'm going to go down. This is an x value. The y value is -3. X value is 4, y value is 5. Okay, now these are y values. So now I'm going to look in the second row. So here's -3, that's a y value. The x value is 2. Y value is 2, x value is 0. Y value is 4, x value is 6. And we're going to get ready to graph inverses, and all you have to do is switch the ordered pairs. Okay, let's see, where am I here? 15, 14. Okay, so we're not going to do all of these. Let's see, I'm going to cross off 18 and 19. There's 2 graphs for each. That's the last page. Okay, so if I see x equals, that also means inverse. So I'm going to graph the function, which is f of x, and then the inverse, which is x equals. So I'm going to go and graph this like I normally would graph it. So I'm going to go down 1, and then my slope is 1/2. So up 1 over 2, up 1 over 2. Then I'm going to connect. I'm going to use a straight edge. So there is that one. Now if you notice, these two are almost exactly the same. The only difference is that x and y are switched, because if you recall, f of x just means y. So just by switching x and y around, that's going to be the inverse. So what I'm going to do to graph the inverse is I'm going to pick the 3 points that I plotted. So I got 0, -1, 2, 0, and 1, 2, 3, 4, 1. I'm going to switch those literally around. So I'm going to get -1, 0, 0, 2, and 1, 4. So I'm going to plot those points. And connect. And now I have the inverse. Okay, 15. So this is y equals x squared plus 2. If I switch this x and this y around, I get x equals y squared plus 2. Therefore, these are inverses of each other. So first I'm going to graph this one. So I'm going to go up 2. And this x squared means it's a parabola. So over 1 up 1 in both directions, and then over 2 up 4 in both directions. Okay, now if I want the inverse, I'm going to pick 3 ordered pairs on this graph, probably the ones that are clustered together. So 0, 2, 1, 3, -1, 3. We're going to reverse those. So 2, 0, 3, 1, 3, -1. Now I'm going to plot those 3 points. Looks like the parabola this time is going to be sideways. So I'm going to turn it this way, and then I'm going to finish the parabola. Over 2, up 4. So if I have a parabola that opens up, originally the inverse is going to open to the right. Okay, 16. I'm going to first of all go up 3. That negative means it's going to be an upside down parabola. So here's the y equals negative x squared plus 3. If I switch x and y around, x equals negative y squared plus 3, I'm going to get the inverse. So I'm going to pick the 3 points that are clustered in the middle, 0, 3, 1, 2, negative 1, 2. I'm going to switch those around. Okay, I'm going to plot those 3 points now. And if I look, my parabola is going to open to the left this time. So I'm going to turn it this way, and I'm going to graph the rest of my parabola. So if my parabola opens down, the inverse is going to open to the left. Okay, it looks like we have one more to do. It's number 17, because again, I crossed off 18 and 19. Okay, so f of x, that's just y. So I have y equals the square root of x minus 3. Its inverse is going to be x equals the square root of y minus 3. And again, we just switched x and y around. That's all we do. So this means I'm going to go to the right 3. And this time my graph is going to be a fishing pole. So from there, I'm going to go over 1 up 1, and then over 4 up 2. So now I'm going to take those 3 ordered pairs, and I'm going to switch those around as well. Okay, so 0, 3, 1, 4, and 2, 7. So that's what the inverse is going to look like. So that is, again, for 9.